Hello students, my name is Saima Aleem, Assistant Professor from the Department of Computer Science and Engineering, Khwaja Muhinuddin Chishti Language University. Today we are going to continue our previous topic, which was graph, and in graph today we are going to cover adjacency matrix. As we have already discussed about graph terminologies, a graph is a mathematical structure for representing relation. It consists of set of nodes connected by edges. Any two nodes which are connected by an edge in a graph is called adjacency node. Suppose if we have two nodes and these two nodes are connected by a line, this line which is going to connect two nodes are known as adjacency adjacency node. A graph can be represented through adjacency matrix, adjacency list and adjacency multilist. Today we are going to discuss about adjacency matrix. In this representation, a graph is represented using matrix of size of the total number of vertex by total number of vertex. It means that if we have three vertex, the matrix which we are going to design by this three vertex is of size 3 into 3. Means if we have three nodes, then the size of the matrix is 3 into 3. The adjacency matrix is represented through rows and columns, and these rows and columns represent vertex of the graph. In a graph G, V, E, where V is the set of vertex a graph can have, it is of the size n by n. Adjacency matrix of undirected graph is always symmetric, and adjacency matrix of directed graph is not symmetric. It means that if we have a direction in a graph, it means that we can go from one node to another if there is a direction, and if there is no direction, then we can travel from initial node to destination node and destination to initial node. As we can see that if in adjacency node 1 indicates a direction from vertex I to j, and 0 indicates that there is no edge between two nodes. We will explain this. This matrix is filled with the adjacency matrix is filled with either zeros and ones. Here 1 represent an edge from row vertex to column vertex, and 0 represent that there is no edge from vertex and from row vertex to column vertex. Here is a graph, and it is undirected graph, and we are going to make adjacency matrix for this undirected graph. This is undirected graph. Now I am going to make adjacency matrix for this graph. In this graph, A, B, C, D, E are the vertex. So I am going to take this vertex here, A, B, C, D, E, rows as well as in column A, B, C, D and E. Now I am going to make adjacency matrix for this graph. It is a undirected graph. It means that if there is edge between two nodes, we will put 1, and if there is no edge, we will put 0 in row and column of the corresponding node. Here I am going to make a self loop on node Is there any edge or self loop on vertex A? No. Then I am going to put 0 here. A to B, there is an edge, so 1. A to C, there is an edge. From A to D, is there any edge from A to D? If it is, if edge is there, we will put 0. And here you can see that there is no direct edge between A to D. So I am going to put 0 here. A to E, is there any direct edge? No. Okay. From B to A, as this is undirected graph, we can travel from A to B as well as B to A. So B to A, 1. B to B, is there any self loop here? No. Then we are putting 0 here. B to C, 0. B to D, there is an edge. B to E. Now consider node C, and we are going to fill this adjacency matrix corresponding to the node C. From C, is there any edge to A? Yes, there is edge. From C to B? No. Then we are going to put 0 here. C to C, no self loop. C to D, yes, there is an edge, and we are going to put 1. From C to E, there is no direct edge or adjacency edge, so I am going to put 0 here. From D to A, no. From D to B, yes, there is an edge. From D to C, yes. From D to D, there is a self loop here, so I am going to put 1. D to E, from E to A, there is no direct edge. From E to B, there is an edge. From E to C, no direct edge. From E to D, there is an edge. And from E to E, there is no self loop. So I am going to put 0 here. So this is adjacency matrix for this graph, this undirected graph. Now let's make a directed graph and try to make adjacency matrix for the directed graph. For the same graph, I am going to make a direction from A to C. Okay. From A to C, from A to D, from B to D, from D to E, from B to D, D to B, and C to D. There is, let's make one more edge, D to E. Now let's make adjacency matrix for this directed graph. A, B, C, D, E. Now in this graph, if there is a direction between two nodes, then we are going to put 1. And if there is no direction, then we will put 0 in corresponding area of the matrix. If is there any self loop at the node A? No. Then we are going to put 0 here. From A to B, is there a direction from A to B? Yes, there is a direction from A to B. So we are going to put 1 here. From A to C, yes, there is a direction from A to C. From A to D, there is an edge between A to D. These two vertex have an edge. You can see that there is an edge. A to D is having an edge, but there is a direction on this edge. And the direction is from D to B, not A to D. So from A to D, there is no direction, and we are going to put 0 here. A to E, there is no direct edge. From B to A, there is an edge, but the direction is not there. So we are going to put 0 here. From B to B, there is no self loop. From B to C, there is no direct edge. From B to D, there is an edge. From B to E, edge is there. From C to A, edge is there, but direction is opposite. So there is no direction from C to A, and we are going to put 0 here. From C to B, there is no edge. From C to C, there is no self loop. From C to D, there is an edge. And from C to E, there is no edge there. Let's consider node D. From node D, there is an edge from D to A, and I am going to put 1 here. From D to B, there is an edge, but direction is there, and the direction is from B to D, not D to B. So I am going to put 0 here. D to C, no. From D to D, yes, there is a self loop here, and I am going to put 1 here. From D to E, there is one edge, and you can see that from E, there is no outgoing edge. And if there is no outgoing edge, then there is no path from, we can travel from E to any other node in this graph. So from E to A, no edge. From E to B, there is no edge. From E to C, 0. From E to D, 0. And from E to E, 0. So the adjacency matrix for this directed graph is this, and we can make the same concept for the weighted graph. If the edge contain weight, so corresponding to zeros and ones, we can put the weight which an edge is having. Let's make a weighted graph. Let's make adjacency matrix for this weighted graph. Instead of writing zeros and ones, now we will take the weight which an edge is having. Now from A to A, there is no self loop, so we are going to put 0 here. From A to B, there is an edge and which is having a weight of 2. From A to C, H having weight 8. From A to D 0. From A to E 0. From B to A there is no H. B to B 0. B to C 0. B to D 10. And B to E 9. C to A 0. C to B 0. C to C 0. C to D 6. C to E 0. D to A 3. D to B 0. D to C 0. D to D, let's take weight of 8 on the edge corresponding to the node D. D to E 14. This is the adjacency matrix for the weighted graph, and we will continue this topic, and in the next video I am going to discuss adjacency list. Thank you, students.